Lesson 4-02, everybody. I hope you got the notes printed out, or at least that you're looking at them, because I want you to pause the video right now and see if you can fill in this right here. Suppose you accept these two conditional statements, and you know what that means. We just learned about conditional statements in the last lesson. Here's two of them. Suppose you accept those two as being true. I want you to try to come up with a new conditional statement that is a combination of the two that are written above. It combines what you believe to be true from these two into a new conditional statement. And this new conditional statement has to have one simple hypothesis and one simple conclusion. So I've given you the format here, the if and the then. You just fill out one simple statement here and one conclusion there after the then. Pause the video, see what you can come up with. Okay. Now, if we were in class, I'd ask a lot of people for their responses. And a lot of responses might be pretty good responses, but not exactly what I'm looking for or what I need you to figure out how to do. So don't feel bad if you came up with something here that's not exactly what I need you to come up with, because this can be tricky to get a hold of from the beginning. But here's what I'm looking for. If you do the homework, you're going to have more confidence going into the test. And if you have more confidence going into the test, you're likely to do better on the test. So by sort of smushing these two together, sandwiching them together, or connecting them, or chaining them together, we can say this: if I do the homework, comma, that's it. That's the whole condition of this new conditional statement. If I do the homework, then, now how are we going to finish this? I mean, we already have a conditional statement that says, if I do the homework, then I'll have more confidence going into the test. So if I just write, then I'll have more confidence going into the test, I haven't written anything that's not already there. I want something new. So what am I going to finish this with? Well, again, I want one simple conclusion, a complete statement that's just a simple statement, not a compound statement, not a multiple conclusion thing, just one simple conclusion. And that one simple conclusion that I'm driving at is, I am likely to do better on the test. Period. Okay? So now, this is the answer that I want. This is what I want you to be able to come up with. What is quite obviously missing from this conditional statement that was present as part of both of the original conditional statements? Something's obviously missing, right? What is it? It's the part about the confidence. Okay? That was the conclusion of one conditional statement. It was the hypothesis of the next conditional statement. And in this new conditional statement, it seems to have disappeared, dropped out completely. Okay? And it's true. There is no evidence in this conditional statement of what it was or is that is connecting these two parts of this conditional statement. If I just showed you this conditional statement and didn't show you anything else, you couldn't possibly know that they came from two separate conditional statements where confidence was the link between those two. That information is kind of gone. It's lost. Okay. So I'm not looking to preserve, by combining these two statements into a new one, I'm not looking to preserve all of the information that was in the original statements. I'm just trying to come up with a new statement that has one simple hypothesis and one simple conclusion without all of the stuff in between. And I think you would agree that if these two statements are both true, if we accept these as true, then this statement is equally true, right? I mean, if it's true that if I do the homework, I'm going to have more confidence, guaranteed. I mean, let's just not allow any ifs, ands, or buts about that. If I do the homework, guaranteed I'm going to have confidence. And if I have more confidence, guaranteed I'm likely to do better. Then you can throw out the confidence part and say, if I do the homework, ultimately, the ultimate conclusion of that is that I'm likely to do better on the test. Right? So this is the essence of today's lesson. It's about combining multiple conditional statements into a single, simple conditional statement that leaves out a lot of what was in the originals. Okay. And some of the work we're going to do moving forward, we're not just going to leave out one item, we're going to leave out multiple items. Okay. That's what today's lesson and the work is about. So let's look at example number 2. Okay. Now, these are not written in English, these are written in logical symbols. If G implies M, and M implies W, and W implies K, I want to come up with a single conditional statement, one simple conclusion, just one letter here, one letter from this whole bunch, and then one letter here. No ands, no maybes, no other arrows, just one single conditional statement. I want it to be a combination of all 3 of these, not just 2 out of the 3, all 3. Right? Some of you are probably already figuring you know what I'm driving at here. Okay? And here's what I want to come up with. G. If G, then ultimately what? Now I don't want to write M because I already have a sentence that says G implies M. That wouldn't be new. I want a new statement. Right? But G guarantees M, and then M guarantees W. You see, this is sort of like dominoes falling. You've all seen, you're familiar with the idea of tipping one domino, which causes a second one to fall, which causes a third one to fall, and so on and so on. So ultimately, tipping the first domino topples the ultimate conclusion is that last domino at the end of the chain or at the end of the line is going to get toppled. If I push this first one over, the 10th one falls. Because pushing this first one tipped the second one, which tipped the third, which tipped the fourth, and so on. But we're just kind of putting all of that together and saying, so if I tip the first one, then the last one's guaranteed to fall, right? So this first condition tips this. And then that tips that. So if G, then W. G is guaranteed to lead in W because G leads to M and M leads to W. So cross out the M's. Take the M's out of the whole system. G is guaranteed to lead to W, but W leads to K. And so ultimately, G leads to K. That's what I'm looking for you to be able to do. This conditional statement is a combination of all 3 of those, not just 2 out of the 3. And it's really the only, I take that back. It's not the only. It's probably the only answer you would come up with. There actually is a second answer that you could come up with. Maybe we'll come back to this by the end of this video lesson. Okay, but I don't think you could possibly come up with it yet until we learn a little bit more. So let's look at number 3. Now, number 3 presents a couple of problems. Okay, and again, if we think of these as dominoes, and we say if we tip this domino, if we tip the H domino, the R domino falls. Well, the problem is that this next sentence does not tell us what happens if the R domino falls. It doesn't say anything about R. Right? So how do I connect these 2 things together? Well, some of you may be noticing that there are 2 There's the presence twice of the letter H in these conditional statements, except in one statement it's an H, in the other statement it's a not H. Okay, it's like, how do you connect those two things together? If you're trying to do it, stop. Just stop. Okay, stop. No, I don't want to hear your answers. Okay, you're going to hurt yourself. Just stop. Okay, there really isn't any way to connect these two statements the way that they are currently written. Okay, but again, that suggests, well, what if we wrote one of them in a different way? Is that possible? Could we rewrite one of these statements to look different? Well, yes, we can. And you learned how to do this in the last lesson and on the last homework. You learned that the contrapositive of any conditional statement is logically equivalent to that statement, or means the same thing as that statement, communicates the exact same information as that statement. And you learned how to write a contrapositive. So let's choose one of these statements, okay? Because I'm not sure if there's one that we have to write the contrapositive of, and if there is, which one. So let's just pick one and write the contrapositive and see what happens. Let's pick this first one. H implies R. What is the contrapositive of H implies R? Oh, do you have to think hard to remember? You don't want to have to think hard to remember. Okay, you got to know this because you're going to be writing contrapositives many, many times on this homework assignment. In fact, you will never be writing, well, you won't be writing converses unless I order you to, and you won't be writing inverses unless I order you to. But in all of these kinds of problems where I'm asking you to combine logical statements, multiple logical statements into one, the only thing you're ever going to be writing is contrapositives. So you got to know how to do that. You're going to be doing it many times. Okay? Need a reminder? Contrapositive is swap and negate. Swap and negate. So we're going to swap the R and the H. Oh, but we also have to negate both of them. So it's going to be not R implies not H. Now, here's what I like to do, and I strongly recommend you do this also. Once I have written the contrapositive of a statement, I like to cross out the original statement. Okay? Because now I have a new looking statement, which means the exact same thing as the original. I don't need the original hanging around anymore. It's of no use to me. Okay? And if I keep it around and if I keep looking at it, I'm going to get distracted by it and I'm going to get confused. Do this. Anytime you write the contrapositive of a statement, cross out the original where it came from. And now look at what I've got now. See, now I have this second original statement and a new version of the first statement. And do you see how this has been helpful to us? Because now there is a link between those two statements, right? A common link. It's that not H. Tipping the not R domino causes the not H domino to fall. Not R leads to not H, and not H leads to A. So tipping the not R knocks over the not H, and the not H knocks over the A. And so ultimately, tipping the not R leads to knocking over the A. Not R implies A. This is a combination of both of the original statements. Okay, and granted, I had to rewrite one of the original statements, but this is exactly the same information as the original statement. Okay. So there's one good answer to this problem. Okay, but there is a second good answer, and we're going to find it before we go on to number 4. Okay. Suppose, again, backing up, starting the problem over, maybe you remember at some point in the problem I said, well, I can write the contrapositives of these statements, but I'm not sure which one I need to write the contrapositive of. I mean, clearly we can see now I did not have to write the contrapositive of both of the original statements. I managed to solve the problem just by writing the contrapositive of the first one, but not the second one. So did I get lucky? Is the first one the one that I had to work on and write the contrapositive of? Let's find out if I had made the other choice. What would happen if I made the other choice? Write the contrapositive of the second statement instead of the first. Okay, let's see what happens. Once again, to write a contrapositive, you have to swap and negate. So this new contrapositive is going to start with not A. And that is going to imply H, just H, right? Because the opposite of not H is H. Now, take your pen and cross out the original statement. Okay. I started with two statements. I should never have more than two statements that I'm trying to deal with in my head. Okay. And for that matter, you should only ever try to deal with two statements at a time. If you've got 3 or 4 statements in a problem, you can only deal with 2 at a time. Okay. So here I've got these two statements. H implies R and not A implies H. Is there a common link between these two conditional statements? Is there a domino that will tip over a second that will then tip over a third? Can we combine these two things? You might be thinking yes, you might be thinking no. Okay. If you're thinking no, it's probably because you're thinking we would not be allowed to change the order in which these two statements are written. You're probably looking at them in the order that they're written and saying, well, H tips R, but still we have no information about R tipping anything. So you can't combine them at all. You're stuck. That was the wrong thing to do. But hey, why couldn't we just take this statement? Where's my pen? Take this statement first. I'm just going to rewrite it. Not A implies H. And again, I don't want to deal with more statements than I started out with. So cross this out. And then rewrite this one next to it over here. H implies R. Now get rid of that. There is no law saying that you can't do that. Just change the order of two conditional statements, because there really isn't any kind of order to them to begin with. I mean, yeah, there's an order in which I wrote them, but there's not a logical order in which they come. One does not exist before or after the other. Okay? So we can change the order of conditional statements. What you can't do is you cannot change the direction of an arrow. Okay? You cannot change the order, so to speak, or the direction of an arrow. Don't ever do that. Okay? But once I place this statement after the first one, now you can see, all right, there's this common link between these two conditional statements. There's the domino in the middle, right? So not A topples H, but then H topples R. And so not A leads to R. That is a good answer to this question. A second good answer, right? Look at these two answers now. not R implies A. That's an acceptable answer to the combining of these two original conditional statements. And then not A implies R is a second, different looking, acceptable answer to combining these two logical statements. Do you notice anything about these two answers? I'm sure somebody does. There is a relationship between these two answers. What is it? There you go. I heard somebody say they are contrapositives of each other, right? What is the contrapositive of not R implies A? Well, swap them and take the opposite of both. You would get not A implies R, and that's that answer right there. Dang, my pen, come on. These two are contrapositives of each other. And again, the contrapositive of a statement sounds different, looks different, but says exactly the same thing, communicates the exact same information. Okay? It's sort of like, giving me an answer of 3/2 or 1.5. Looks different, sounds different, exact same value. Okay? So for these kinds of problems, when I'm asking you to combine multiple conditional statements into a single conditional statement, there will always two good answers. Because whatever answer anybody comes up with that is valid, the contrapositive of that answer will always be valid. Now, I'm not going to ask you ever to give me two valid answers. Please don't. Just give me one, okay? I will know what both of the valid answers are. I'll have them both on my answer key, and it doesn't matter which one you give me, but don't give me both. You don't have to do that, all right? So now I want you to try to do these two problems on your own. I'm going to ask you to pause the video in a minute. I want you to combine these three statements into one. I want you to combine all three of them down to one. And in this problem, all four of them down to a single conditional statement. One letter as the condition, one letter as the hypothesis, which must be a combination of all of them. And you are going to have to write some contrapositives of the statements that I gave you in order to chain these things together. Okay? Turn the video off right now and give it a try. All right, I'm going to assume you tried them on your own. Really, you're not just watching me. Okay, it really would help if you try these on your own first. Now, again, there's no way to chain all three of these together as they are. There is a way right now to chain two of them together if I just change the order in which they are written, right? And that's what I like to do. I like to look for conditional statements that can be combined without writing any contrapositives if I just change the order in which they're written. Okay? And the only way you're going to find that is to find a letter which is identical but exists as the hypothesis of one statement and the conclusion of a different one. Well, that letter in this case is the letter T. It's the hypothesis of one, but it's the conclusion of the other. But those statements are like kind of not in the right order for me to see how they chain together. So I'm just going to take this T implies V, and I'm going to move it over there. T implies V. Cross it out, because now I got four statements, whereas I only had three to begin with. I never want more than three. And now I've got this domino effect. Q topples T, which topples V. So now I can combine these two into Q implies V. And now I'm going to cross out those two. Now I have, in effect, reduced two of those statements down to one. It's like reducing a fraction, right? You're simplifying the value of the fraction. And I am simplifying these conditional statements from three now down to two, because I took two of the three and combined them into one. And again, I crossed out the two now, because now all I want to see now is the two that I have remaining. If I have any others up there that are still plainly visible to me, I'm going to get distracted. Right? But again, these two statements can't be combined, no matter what order they're written in. Do you see the common letter? I'm sure you see the common letter. It's Q, right? But this is a Q and this is a not Q. Do not make any attempt in your head, okay, to try to figure out how these are going to be combined until you write the contrapositive of one of them. Okay? Which one do we have to write the contrapositive of? Which one do you think? Yeah. Well, the first or the second? Okay, right. It won't matter. Okay? You can write the contrapositive of the first one or the second one, and we'll find that we're able to combine the two final statements together. It's just that if we write the contrapositive of the first one, we'll get one answer. If we write the contrapositive of the second one instead, we'll get a different answer. But those two different answers will just be contrapositives of each other. And they're both going to be okay, right? So, I don't know. Let's write the contrapositive of the first one. Okay. Swap and negate. So swap the S to the front and negate it, not S. Swap the not Q to the back and take the opposite of not Q, which is Q. Okay, now cross that one out. Okay. Because I just had two statements. I created a new one, which gives me three. Cross out where it came from, so I still only have two. And now we can combine these two just the way they're written because we've got that common domino in the middle. And so not S implies T. Okay? Now, the other perfectly good answer to this question is the contrapositive of this one. And some of you might have come up with that. Not T implies S. Either one of these answers is perfectly acceptable. And again, you do not have to give me both. Okay? Last example, and this video lesson's done. Okay? Oh my gosh, 4 statements. Your mind's going to go crazy trying to put 4 statements together all at once. You can't do it, okay? Just find 2 that have a common letter between them. This first one has an A and a V. This has an X and an R. There is no common letter between those two. Can't do anything with those two. But here, A and a V, J and an A, okay, they have a common letter, A. I can do something with those two. And in fact, the A is identical. That's A and that's A. It's not like one of them's an A and one of them's a not A. And because they are exactly the same, and one's in the hypothesis and one's in the conclusion, I can combine those two statements just the way they are. And in fact, really, I'm not going to insist that you rewrite these two statements and put the J implies A in front of the A implies not V before you combine them together. I think pretty much all of you out there can, in your heads, realize that these two can be combined to give you, careful now, J implies not V, right? Because to combine these two statements, really the A has to be the domino in the middle. And the way they're written, it's not in the middle. The way A will be in the middle is if you move the J implies A over to the other side, and then when you combine them, you get J implies not V. So this new statement here is the combination of this one and this one. So I want to cross them out. Okay. And now I have reduced the 4-statement problem down to 3 statements. I'm trying to get down to 1. And when I get down to 1, I'm done. Okay. So now I've got a new statement. J implies not V. And here's an X implies not R. None of those letters are the same. So I can't combine those two. Okay. But I do have a J implies not V and a not V implies X. Isn't that convenient? right? I mean, if J leads to not V and not V leads to X, those two statements can be simplified or reduced down to J implies X, because that not V is that common domino in the middle. When you tip J, it tips not V, and not V tips the X. So ultimately, J causes the X to fall. Now cross out, please, once again, cross out the two statements that this new one came from. Now I'm down to two statements, right? The only two that I haven't crossed out, the J implies X and the X implies not R. These are the two that I have left, and I think you see how they can be combined. J tips the X and X tips the not R, so J ultimately tips over the not R. And that is the final statement, which is a combination of all four of the original. Occasionally, when I give quizzes on this kind of stuff, students will turn in an answer to me that has really only combined 3 out of the 4. And you can't get full credit for that. Okay? Got to combine all of them and get them down to 1. Right? Now, again, there's another good answer to this problem. Another good answer could have been the contrapositive of this one. R implies not J. Okay. We could have come up with that. If we had just taken different contrapositives, or started the problem from a different place or something. All right. Much of the homework is like this, but, I got to bring up the homework. Wow, and I wasn't prepared to do this, but let me bring up the homework right now, because